Okay, let's solve some radical equations or some square root equations. Um, you are solving these just like you solve every equation. You're using inverse operations. You're trying to isolate that variable and get it all by itself. So I've got an m plus 3 that's underneath the square root, and it's all by itself. There's an 8 on the other side. If I were to square both sides, square and the square root cancel out, leave me with m plus 3 is equal to 8 squared is 64. We subtract 3 from both sides, we get 63 equals m. Not too difficult, is it? Let's try another one though, shall we? All right, this time, instead of an 8 on this side, there's a p on this side. Let's see if that makes anything change. We square root both sides, we get p, or we square both sides, we get p squared equals 42 minus p. And this is where everybody loses their minds. Okay, we got a p squared and we have a p. So what do? We can't use just your typical inverse operations, because if we try to square root this, we end up with the square root we started with, we end up with a problem. So what do? You want to get everything to the other side. P squared plus p equals 42. And subtract 42 from both sides. And we get p squared plus p minus 42 equals 0. What is this? It's a quadratic. What do we do with quadratics? We could factor them. We could use the quadratic formula. We could complete the square. Whatever you like to do. I like to factor if I can. There are factors of negative 42 that add up to 1, then I am happy. 7 and negative 6. This factors into p plus 7 times p minus 6 equals 0. And how does that help us? Well, there's two ways that this could become 0. If the first factor is 0, doesn't matter what the other one is, 0 times anything is 0. If the second factor is equal to 0, doesn't matter what the first one is, anything times 0 is 0. So we're able to look at them separately. We see that if p equals negative 7, the first factor is 0. And if p equals 6, the second factor is 0. So now we just got to figure out, are those solutions to the original problem that we had? So let's see. If I plug in a 6 here and a 6 here, what's 42 minus 6? 36. What's the square root of 36? It's 6. So that works. P equals 6 is a solution. Now let's try the other one. This is where square root functions are a little bit different than the other functions. If we plug in a negative 7 here and a negative 7 here, what's 47 or 42 minus negative 7? It's 49, right? What's the square root of 49? 7. Not negative 7. So what happened? Well, when you square things, when you square something, the operation isn't able to distinguish any difference between negative 7 squared, which is 49, and 7 squared, which is 49. So what happens is we end up with sometimes a solution that appears to be a solution, but is actually not a solution. This is called an extraneous solution. And that's what we get in problem number 48. Just 1 second, we'll do number 49. We are ready to rumble. This one has 2 things on this side instead of just 1. So what shall we do here? We're going to do the same thing. We're going to square both sides, but when we square both sides, we have to square x minus 8, not x and negative 8 squared. We have to square x minus 8. So what does that look like? It looks like x minus 8 times x minus 8 equals this square and this square root cancel each other out, 8 minus x. So now we've got to FOIL this out. That means the first times the first, which is x squared, the outsides, x and negative 8, which is negative 8x. The insides, negative 8 times x, which is another negative 8x. And the last, which is -8 times -8, 64. Combine some like terms over here, we get -16x, and then I'm going to add another x. We'll have x squared minus 15x now. Then I'm going to subtract 8 from both sides, plus 56 equals 0. What do we have here? It's another quadratic. Can we solve this quadratic? Yes, quadratic formula would always work. I think it's kind of a pain, so I try to avoid it if I can. And the way I avoid it is by factoring. Are there factors of 56 that add up to -15? Well, if there are, they're going to have to both be negative, because two negatives multiply to make a positive, but can still add up to a negative number. And what are those factors of 56? 8 times 7 is 56. So this would be x minus 8 times x minus 7 equals 0. So my two potential solutions, x equals 8 and x equals 7. So now we have to do that work. Notice we mainly do this, and we mainly see this become a problem when we have a quadratic to solve. Once we get a quadratic, we're going to need to go back and check. So if I plug in a 7 here and a 7 here, then I get -1 equals the square root of 1. There's a problem there because the square root of 1 is 1. It's not -1. So 7 is actually not a solution. What about 8? That would say 8 minus 8 is 0 equals the square root of 0. Well, that's true. 0 is the square root of 0. So x equals 8 is a solution. 7 is an extraneous solution. All right, that's all we've got for square root functions. We'll have one last video and we will cover probability.